Good morning all, how are you all? I hope you're well. My hair looks terrible, but that's not something I'm really fussed about at the moment. Unfortunately, when you're on the night shift, you just take whatever sleep you can get. The sofa was very comfortable for me last night. So, we are today going to be looking at investigating maths. It's the second one. If you haven't seen the first one, this kind of follows on from there. I'm trying to teach you all how to investigate properly, because a lot of students I've noticed, they treat maths like, what does Mr. Harris want me to do? I'll do what he tells me. Not, I'll explore or I'll discover. And really, maths should be about discovery and exploration. So in a second, I'm going to talk to you about what we're going to learn today. We're going to mainly do a single problem together. And I'm going to talk you through a couple of steps I want you to learn. Because today we're going to be looking at being stuck and aha moments. So back in a second. So I hope you're all well. Good morning to everyone in the chat. I can see quite a few people. JJ and Nina have been having quite a chat this morning. And Isaac and Harry are here. And Sharanya's here. And a few other people here. Sasha at St Albans is here. So lots of different people here. Nice to see you all here. We are going to be talking about being stuck and aha. And to do so, I'm going to go straight, not going to use a PowerPoint today, I'm going to go straight to my whiteboard. So hopefully you can see that, and I'm on the page above where I want it to be. So we're looking at the patchwork problem. Now, in order to talk about today, we're going to first of all remind what I discussed last week. Last time I discussed generalizing and specializing, and we're going to look at that as well. So we're going to, every time we do a problem, we're going to always consider our approach. Today we want to introduce some new words. We're going to introduce the word rubric. We're going to introduce the idea of stuck and aha. And we're going to talk about the questions we need to ask ourselves. So what do we know? What do we want? So what do we know and what do we want? So these are the four things we're going to talk about. So first of all, we've got this new word. I'm sure the other words people will know, but rubric. Rubric is like a written account of a problem. So as you solve the problem, kind of like a written commentary to how you solve the problem. It's how you might lay out any form of investigation where you want people to be able to follow what you did. It's kind of halfway between your normal maths work that you used to do where you just do questions and like writing a journal. So it's like a maths journal. Your rubric should explain your thinking. And it's very useful for you, not for a teacher, although it is useful for a teacher. This is the sort of maths we're trying to look at the moment, is teacherless maths. How we can explore problems without needing a teacher to tell us what to do. Because, let's be honest, that leaves us quite trapped. If we rely on a teacher to do our maths for us and tell us what to learn and what to think, we don't actually become individuals. So that's one of the things I'm trying to introduce. So we're going to look at this patchwork problem. What is it? The patchwork problem says, and I'll read to you, take a square and draw a straight line across it. Okay, I'll do that. Take a square and draw a straight line across it. It then says, draw several more lines in any arrangement so all the lines can cross the square. Okay, so there's a line, there's a line, there's a line, there's a line. The task is to colour the regions in such a way that adjacent regions are never the same colour. How few colours are needed to colour any such arrangement? So, first thing we do, when you come across a problem like that, the first thing, and it comes under specialising, is try it now. So before we do any thinking, really, we're not going to do any thinking, we're just going to try it out. So I'm going to colour this one in green. And I think I'm going to colour this little bit here green. And I fancy colouring this bit green. You just can't have green next to green. I'm now going to do some purple. Do that one like that. So I've coloured that one in purple. And I coloured that one in purple. If you've got paper and pencil, feel free to join me while we're doing this. That's one of the cool things about these videos. You can pause them and take part yourself live. So I've got a purple bit here. I've got a red. I'm going to put that red here. And I've got a big bit of red in here. My colouring's not the best because I'm on a tablet, but you can see what I'm trying to do. No more red. I think a light blue in here. And a light blue in here. So all I'm doing is making sure that no colours touch each other. I'm just trying out the problem at the moment, because the problem says how few colours can you use, what's the minimum number of colours you can use. But I'm just going to do it randomly first, because I just want to get a feel for what the problem is asking me to do. And this one can be light blue as well. And that leaves one more, which I'm going to make yellow. That yellow. It's like orangey yellow. But I think you'll agree, we've proved here, it's definitely, it looks pretty, but we've proved it's definitely possible to do in 5 colours. We've proved, we haven't proved anything, but we've got a solution which works for 5 colours. So it's definitely possible to do this one in 5 colours. It's not necessarily possible to do everyone in 5 colours, that's not a proof. We've proved it's possible to do this one in 5 colours. But this is basically what we do now. We do a try, we do a specialise. Okay, so we can touch at the corners. So you can see the blue here touches the blue at the corners, but they can't touch on a side. They can't have an edge that touches each other. So why not, unless you're watching live, when you might want to interact with me live, if you're watching this later, pause the video and draw one of your own. Can you do it in 4 colours? So what you're first of all doing, that's all we've done so far. We've specialised and tried it now. But the question says, how few colours are needed? So this is where we talk about the stuck and aha bit in our rubric. So in a rubric, which is a written account, we've just said that, what we're going to do is we're going to need to write a few notes. It doesn't need to be too verbose, but I have tried an example, need an N because it's an example, and completed with 5 colours. Because I've written that now, I can rub out the bit that says 5 colours. Now, it may well be, therefore, that we now have some stuck, some queries. This is the first thing to realise. And it's a biggie. And to do so, I'm just going to quickly bring myself on the screen, because this is something I need to kind of get across to you, and I need to convince you, because being stuck is important. I see lots of people react in different ways to being stuck. I see people trying to deflect, people trying to bury their head in the sand, people trying to hide, people trying to turn their attention onto other people, people trying to be... I've even seen some people being a little bit aggressive with it because they don't like being stuck. But actually, to be good at maths, which is something everyone can do, just with enough practice, to be good at maths, you have to be comfortable being stuck. You've got to realise that it is not a problem. So when we're stuck, all we have to do is then say, well, how are we stuck? So, I'm stuck. I don't know what to do now. So this is what the purpose of these 2 questions are. And I need to bring back the purple. What do I know? And what do I want? So what do I know? And you literally write down, know. We know that we make grids with squares and straight lines. That's in the question. We know that from the question. So what do I know is basically look at the question, read the question again. What do you know? What else do we know? We know colours may touch. Someone's already asked a brilliant question in the chat. They said, can they touch at corners? So this is where we pose a question. I like to use a different colour here. Can the corners touch? So we then go back to the question and it says, so when we read the question again, it says, regions having only one point in common are not considered next to each other. So yes, they can. The corners. So this is where we get the stuck and aha. So this would be called an aha moment. because it's a thought moment. An aha moment is any time you go, oh, I can do that. So I've written on the screen here in blue, aha moment. Can the corners touch? Yes, they can. What we knew is we make grids with squares and lines, and no colours may touch. What we want to know. So my next thing is, what do we want to know? Well, we go back to the question. It says, how few, the fewest colours needed. Okay, so the best thing we're going to need to do is do some more specialising. Before we can generalise, maybe do some more specialising. Well, this is where we need strategy. So for strategy, I'm going to start a whole new page here, and I'm going to think, well, what's the simplest type of square I can use? Oh, I've copied the wrong thing. The simplest type of square I can use would just have one line on it. There it is, one line. And I think you all agree that's going to just have two colours. So what I've done here is, again, I have specialised. I've done an example, but I've done it using something called systematic approach. Systematic. It's the I think the Attic family have got two children. They've got the brother Matic and sister Matic. So they look after each other, and they go together. So systematically, and all that means is we do step by step, starting simply. So one line we found needs two colours. Well, that was straightforward. Now we can do another two squares. Try two lines, because what we're doing is looking for a systematic approach. One line needed two colours, but I can see two ways of doing two lines, because we could do two lines where they don't cross each other, and we could do two lines where they do cross each other. And let's test those. I'm going to do blue and blue, and I'm going to do blue, and because we've seen about corners, we can do this one as blue. So we can see, hopefully you spotted, we only needed two colours again. This is where, hopefully, no one's stuck at this stage, because we can see what we're doing. We're just trying out some different ones with different numbers of lines. But we may get more stuck moments. And this is the point of these investigations. I think we then write in our rubric, for two lines, the least is still two colours. We're going well. So what's the logical thing? Using a systematic approach. If we're going to be systematic, the next one we do is three lines. Here's another square. I'm going to try and copy it and paste it and paste it. Move it around a bit. Because with three lines, there's probably more than one way to do it. So what we're going to do is we're going to try and make sure the first one, three lines not crossing each other. Now, it does say that's valid in the question. So I've just checked. This one, 1, 2, 3. And now, what about if they all cross each other? So we'll try again. This one seems very sensible. We can just go with that one, and then we colour in this one. This is, remember, maths colouring, so it's shading rather than needing to be too neat, but it can still be neat. I know some of you will be much neater than I am, and that's fine. There's a blue, and another blue. Looks like this one's coming out. So some of you will be starting, if you've got that sort of approach. Some people are very quick to decide things are a fact. And I caution people against that, because you should never assume things are fact just because you've got a little bit of evidence. I see adults are terrible at this. If you go on Facebook, I don't recommend Facebook. It's not very good if you want to see people arguing and going on at each other. But people seem to have one bit of evidence, and that's enough to convince them that they are right. Whereas we know that you need lots of evidence to be able to prove things, and that's why I try and teach investigating to people. I want people to be able to investigate properly, be able to come up with, able to see both sides of an argument. I think is a very important skill to learn. So here we go. These two both work as 2. Does the last one work as 2? Because we're investigating this together. So if I colour this one in red, I colour this one in red, and I colour this one in red, colour this one in red, and I'm just going to save us some time. I can see that that one will work as blue, that one works as blue, and that one works as blue. I'm not going to colour it in too neatly. Okay, so it works again for 3. For 3 lines, the least is 2 colours. So we are investigating quite thoroughly. We're not doing any generalising yet. We're investigating step by step. But here is where it gets important. Here's another square, and I'm going to show you this example. And there's a specific reason I'm showing you this example, because it looks like we've found a rule. And what we can do is we can even write down a maybe in our rubric. Maybe only need 2 colours. But this is why we investigate. Because this is where we go, this one, and 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 this one. Hopefully you agree they're all at the straight lines that are allowed. They all go across the thing. And look what happens when I try my 2 colours. There's the blue. That can't be blue, so that one has to be blue, and that one has to be blue. And that one can't be blue, so that one has to be blue. And that one can't be blue, so that one has to be blue. And this one has to be blue. Yeah, it looks like it still works. So, have I proved it? Well, actually, this is only a complicated one. So, we've only done one example. I now need to go again. So, what about another one? And you have to try more and more increasingly complicated ones, and eventually, you come across all sorts of different things going on. So, this one, I'm going to do that and that and that. That, 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 and that. Now, I've deliberately chosen a quite complicated one to show you. If I start with my red, and then I go to this red, and I go to this red, and this red, and this red, and this red, is it still working? Looks like it to me. And this one, and this tiny bit, and this one, and this one, and this one. Haven't found one that doesn't work yet, have we? So maybe we're getting close to a proof. That looks like it works to me. So does it make it so that we can always do it with it's 2? And what you do is you keep exploring, and it looks like what we've got here is a method that we came up with for how to do it. What we did is we expanded from the original question to say, let's start with one colour and then see what happens when you have that colour all around. And so that had to be white, that had to be white, that had to be white. So because of how I started colouring it in, that one was red, so I made this one had to be blue, and this one had to be blue. So therefore, this one has to be red, this one has to be red, this one. So you can see how I'm building it up and exploring, and there will be moments where we're stuck. So it looks like maybe 2 is the minimum. But unless we explore really complicated ones, and I'd love to see some drawings on the Facebook or post some comments on here. If you find one that can't be done with just 2 colours, that would be really interesting to see whether some people can come up with some diagrams that just can't be done with 2 colours. Now, it's interesting to me because this problem just says, well, what about if we do a square? So how could we extend it? Well, we could say, well, what about if the outside shape was a triangle? Does that work? Investigate. What about if it was a circle? Does that work? Colour it in and investigate. Can you do it only using the right number of colours? That's the key thing, is trying to work out the number of colours you need to use, and can you find one that breaks it? Can you find one that doesn't work? Okay. Now, I've talked about stuck and aha. Let's briefly talk about what they're for. So, stuck. This is where you're like, I don't know what to do. I'm stuck. What I encourage you to do is write down the word stuck and then write, I do not understand, and expand on that sentence. I do not know what to do about, and then explain what you don't know what to do about. I cannot see how, and then I cannot see why. This approach allows you to get stuck but feel that you can talk to yourself to try and at least give yourselves avenues to try. Then you're going to go look for aha moments. Aha moments are where you go, oh, what about this? This is where you try this. Maybe this. But why? You try and work out why. So stuck moments, this is what you're expecting them. You have to go, I'm expecting to be stuck. But then also, aha moments are the way you try and you maybe, and but why? What's going to happen? And then you can always make the problem bigger and smaller. Now, this has been the stuck and aha lesson. What I wanted to do is set you a challenge. It's the die rolling challenge. There's always also a Taskmaster challenge that if you haven't seen it yesterday, this is the Taskmaster challenge for the week. Put the most things beginning with I on a tray. Most different things. I need a photo, even better, a photo of you've annotated the photo and shown me all the different things. Send that to the Facebook group. If you're not there already, go to Facebook and it's School of Mr. Harris, I think, or Mr. Harris School of Maths. You'll find it. This is the die rolling challenge. It's an investigation. I'm going to read to you what it says, and then I'm going to encourage you to. I'll show you briefly what it is. So you've got a die. I've got a die here, sometimes called a dice, and you're allowed to call them dice and die now, and preferably square paper. If you've got plain paper, that's absolutely fine. So what I'm going to do is place it with the 1 upwards. So let's draw that. I have drawn. It's got the 1 upwards, and I rotate it to the right, and now the 5 is at the top. So it was the 1. It is now a 5. I rotate it upwards, and it's a 4. I rotate it backwards, and it's a 1. So it's possible to get from 1 by going 1, 2, 3. But that's weird, because you can't get a 1 by going just forwards. So you couldn't go 1 to 1. So what you're trying to do is you're investigating how to get to different numbers. How would I get from a 1 to a 2, for example? So 1 to a 2, there's the 1. If you go upwards, it changes to a 2. So there's a 1 to a 2. But a lot of it depends on which sides you've got altogether. So you're trying to investigate how many spaces it takes to get to places. To get from 1 to 3, you got a 1. And where's the 3? The 3 is on there. If I go one place that way, it ends up as a 3. So I need to change it to a 1 to a 3. So you're investigating. So it says, mark the square that the die covers with a 1. Now, roll the die over one edge and mark the newly covered square by the number shown. And you're going to experiment. So when you do this, what sort of questions arrive? Do you always start on the first square with the same dice the same way around? So do you make sure the dice is the same way around? Let me show you what that means. If I have the 1 on the top, I could have the 5 at the front. But I could have the 6 at the front. Or the 2 at the front. Or the 3 at the front. If I'm not consistent, I'll get different results. So keep it so it's the same on the front. What numbers do I get on either side? Which direction? So one thing you could do is investigate what happens with a 1 here. What happens if I go that way, that way, that way, and that way? So that gets me that. If I roll it upwards, I get a 4. If I get that way, I get a 5. If I go that way, I get a 3. And if I go that way, I get a 2. So that's one way of looking at it. I could then do the same with a 2, a 3, a 4, a 5. What about 2 spaces up? That is a 1 upwards 2 spaces goes 6. 1 that way 2 places. Oh. So a 1 will always take me to 6 if I go in the same direction twice. What about this way and that way? So if I line it up the same way as I had before, so I've got the 1 on the top, and I've got it the right way around. So I've got it 1. I've got my 4 at the front. If I need to go back to this screen so you can see what I'm talking about. If I go across, it's 2, and then down, it's a 3. But if I had gone instead down, it's a 3, and across, it's a 2. So I can get either a 2 or a 3 depending on which way I go. If I go this way, I get a 2. If I go that way, I get a 3. So we've got there lots of things to investigate. I'd love to see what you discover about placing the dice. Remember to write your rubric. Try, extend. The rubric is your report of what you found out. Specialise and generalise. I'd love to find out what you get on with. This is the die rolling experiment. I have today been teaching you about stuck and aha moments, what to do and how to get out of them. Remember that page is very useful. Ask yourself those questions. Try maybe and put why. Make sure you write down your comments. Make sure you write down your things to yourselves. I hope you've learned something today. I hope you've got something out of it. This is how we're trying to learn to investigate maths thoroughly. Have a go at the die rolling experiment. Have a go at the Taskmaster Challenge. I will speak to you later in the week. I've been Mr. Harris. You haven't. Look after yourselves. Take care.